Hey folks, how's it going? So this is a new video in the Python Tricks series. Python Tricks is a new book that I'm working on. It's like a buffet of awesome features in Python that show you, the whole book is organized in a way where there's small chapters that each show you a really cool feature in Python, like a really practical feature you can apply in your own day-to-day work. And I'm doing this video series to kind of go with the book and of course also to promote the book. So if you're interested in these videos and interested in improving your Python, then be sure to check out the book. It's available for early access right now, so you can get in now and then get all of the future chapters as they come out. All right, shameless plug aside, today I want to talk about a really cool Python trick. And that is a way to emulate switch case statements in Python. So what I frequently see in Python code is that people end up with these relatively long if statements, these kind of chained if statements to decide on what action to take based on a condition in their code. So to give you an example, let's say we had this if statement where we had a condition and we wanted to compare it to a certain value. And then, okay, if we get A, we want to call handle A. And if we get condition B, then we're going to call handle B. And if we get none of these, then we're going to call handle default, right? And you can imagine that this would go on for much longer, and this would get kind of cumbersome, right? And it's a lot of typing, and the reason for that is like Python doesn't really have a switch case statement with which we could use to kind of condense this a bit and make it more terse and just easier to read. So there is actually a way to emulate that switch case behavior in Python, and I want to show you how to do that. And the way to do that is by leveraging the fact that Python has first-class functions. So functions in Python, they're just like any other object. You can pass them as arguments to other functions, and you can return them from functions as values, and you can store them in variables and store them in data structures. So this is actually a really flexible feature in Python. And to give you an example, we can define a simple function here that takes two arguments and just returns the sum of both. And I could actually go ahead and say, hey, I'm going to store this function in a list that I'm going to call my funcs. And then I could just refer to that function and call it, right? So if I did that, I would actually get a result that is 5 because it's adding together 2 and 3, right? I would just, with the index here, just grab the first function in there, which is my func, which we defined up there, and then I can just call it with the braces syntax. So this is extremely flexible, and this is a really cool feature that's going to allow us to emulate how a switch case statement would work. All right, so let's come back to our original plan here, which was emulating a switch case statement. So now that we know about these first-class functions, what we can do here is actually create a function dictionary that maps from the condition name or from the actual condition to the handler function, right? So something like this, where we're just mapping from the condition to the handler function, and then I could look up that handler function just by passing the dictionary, by passing the condition as a key into that dictionary, right? And then I could just call the resulting function. And this would actually be sort of a switch case statement, right? And we could shorten that further. I mean, we don't have to give a name to this. Like we could just do this. And this would already be kind of terse, or there's not a lot of overhead to this, but it has a big downside, and that is we're going to get a key error if the condition isn't found. So there's no default at the moment, right? Like previously with the if statement, we had an else all the way at the bottom, and that would allow us to have a default branch that we can take and a default handler that we would call. And we can't really do that right now. So actually one way around that is, and let me undo some of that. So actually one way around that would be to use the get function on the dictionary. So we could just call get, and then that would either return the value for that key if it's found, or it would return a default. And in this case, we'd just pass in a handle default function that we'd have to define, and then call that. So this would actually solve the problem with the key error, and we'd be able to have a default and have kind of this dispatch based on this function dictionary here, which is already kind of neat. And you can imagine like this becomes really useful if you have many functions that you want to map to, or many conditions that you want to map to functions, because then it actually becomes a lot more efficient than an if-else statement, because an if-else, it needs to try all these conditions in sequence. But with a dictionary, it can actually take a shortcut and do a lookup based on the hash of that condition. That can be a lot faster if you're dealing with many of these mappings. I mean, if you're only dealing, with tens or potentially even hundreds of them, it won't matter. So it would be a premature optimization. But for, a really large number of functions and conditions, this could be extremely helpful. So this could be a really nice trick for you to actually speed up your Python code to optimize it. So now this might look kind of weird syntactically, and there's actually one step we can go beyond this to clean this up, and I want to show you how to do that now. All right, so let's take a look at a little bit more realistic example, a little bit more complex example. So I've got some code here that is an if statement that would do the dispatch for us. So the idea for this would be, maybe we're implementing some kind of virtual machine and we want to be able to pass it an operator and two operands, and then it would look up the operator and then carry out some operation based on that, right? Like would either like add the two numbers or subtract them or multiply them or divide them. So, it's just a little toy example here. Okay, so just to show you how you would use this function, so we're going to call the function, and then we would pass the instruction of the operator to it. So in this case, we want multiplication. And then we would pass two values to it. And the result of that, we would expect the result of that to be 16, right? 2 times 8. And this would just kind of go through that if and say, okay, well, we're looking for the operator is mul. So I'm just going to return x times y. And this is how this would work. Now, if we wanted to implement the same function using this dictionaries as a switch case emulation of sorts, then it would look a little bit different. And I'm introducing another Python feature here into the mix. So let's just walk through that, right? So this would actually be a little bit shorter. And so what this function would do, it would create a dictionary, and then it would define these handler functions with a bunch of lambdas here. So this is a way for us to not having to define these handle add and handle sub and all these helper functions separately, but we can kind of keep that actual behavior in line here. And then we're creating this dictionary, and then we're using the get method on the dictionary with the operator, and our default is just returning none. So, you might have seen here this if we fall through all of the cases and none of them match, the Python does an implicit return none here at the end. Or we could also explicitly add that, and would probably be better for real world code, like doing something like this, or just doing something like this where, there's just no way we can fall through. I mean, in this case, they would both be equivalent. So, I wanted to remove that to kind of show how terse this could also be. But really here you can see that this is equivalent to this code up here. And it looks kind of nice. I mean, it's not like exactly a switch case statement, and there's actually one big downside to this that I want to mention as well. But it works kind of nicely, and it can be a good way to work in these dispatch situations where you want to map, some condition to some kind of behavior, it can be a really helpful way to structure your code. Now, one downside to doing it like this is that you're constructing a dictionary object and a bunch of lambda or a bunch of functions every time this dispatch dict function is called, which is not great, right? For memory reasons and for performance reasons, it's not a good decision. I mean, it won't matter if you're not calling this a lot. It honestly won't matter, and I would go with whatever is cleaner. But one way to get around this would be to take this value or this dictionary and actually store it in some variable in some other place, and then you can refer to it, right? Like if you have this massive dispatch table mapping from condition to handler, I would just cache that somewhere, keep it in a variable, and then in your actual dispatch code, you would just take that dictionary and look up the function and then call the function. And that way you don't have to recreate this dictionary every single time the dispatch function is called. But, like I said, if you're doing this with just a couple of cases and it's not in like a tight loop, like a hotspot in your program, it probably won't matter and it would be premature optimization. I would go with whatever looks better to you. I mean, another downside here is that this is pretty advanced Python. So if you're doing this, depending on the skill levels in your team or the people you're working with, people might have a hard time like dealing with this, right? Because it can be so foreign. Like you need to understand first class function, all of these advanced level features, whereas a nice and clean if statement, it gets the job done and it might actually be the better choice in a lot of situations. So, just want to make sure you are aware of that, but it definitely has its place and it definitely has its applications. And again, I think it's a really cool feature that teaches you about some of the, cool, lesser known aspects of Python. And if you enjoyed this example, then I think you'll really enjoy my new book called Python Tricks. You can get in for an early access with this book right now. So I'm kind of writing this book as we go along. And if you get in now, you can get it for a much cheaper price, and then you'll get updates for free as they come out. And so, feel free to take a look at that. You obviously don't have to. You can just keep watching the videos, but I would really appreciate it. Cool. Well, thanks so much. I hope this helped you out, and best of luck in your Python journey. I'll talk to you soon.